Hello friends, welcome back. Hearty welcome to you. Let's continue with the examples. We are doing examples as part of integration, indefinite integrals, finding out the integral of functions using substitution method and also trigonometric identities. So let's look at this problem and try to solve it together. We have to find out integral of tan cube 2x into secant 2x dx. Now, whenever you see a function which is having, let us say, tan of 2x and we have secant square 2x, then we know that I can take tan 2x equal to t, so that secant square 2x will become part of dt. That we know, but we don't know how to deal with when it is only secant 2x and we have tan cube 2x. So what to do with that? For that, what we will do, we'll say secant 2x equal to t. If I take secant tx equal to t, now if you differentiate it, we'll have 2 secant 2x tan 2x dx is equal to dt. Now let's come back here and try to convert that. So can I write this as now tan square 2x, multiply that with half here, and we'll have 2 secant 2x tan 2x dx, which is nothing but equal to half into integral of tan square 2x. We'll write it out. What is 2 secant 2x tan 2x dx? Nothing but dt. And what is tan square 2x? If secant 2x is t, tan square 2x is equal to 1 plus is nothing but equal to tan square 2x is equal to secant square 2x minus 1, or can I say t square minus 1, because we know the formula secant square theta minus tan square theta equal to 1, or tan square theta equal to secant square theta minus 1. So can I write it as now t square minus 1 dt. Now this is pretty simple because it's of the form x power n and we know how to deal with it very easily. So can I say half integral of t square dt minus half integral of 1 dt. That's equal to half into t cube by 3 minus half into t plus c, that's equal to t cube by 6 minus t by 2 plus c. Now t is equal to secant 2x, so it will become secant cube 2x by 6 minus secant 2x by 2 plus c. So the answer will be secant cube 2x by 6 minus secant 2x by 2 plus c. So what is the approach we have taken? Remember, whenever you have a problem where you have secant square 2x, see, always remember that whenever we are trying to take a function as part of f of x, f dash x should be there and that should be removed so that we can simplify the problem. If I look here, if I take tan x equal to t, I need secant square 2x, but I have only one secant 2x. So now I have to think that I have to take secant 2x as t, then I have secant 2x and also tan 2x here. Left out is another tan square 2x, which I can easily write in terms of secant 2x as secant square 2x minus 1. So that is how we have solved it. Let's go to the next one. Now we have to find out the integral of tan power 4x dx. If you remember, in the last session we have done example integral of sine power 4x, I think. In that, if you remember, always the idea is to reduce these powers and make these functions which are in the form of sine of mx, sine to the power of mx, or cos to the power of mx, or tan to the power of mx into sine ax, cos ax, sine bx, so that we want to reduce the powers. So to reduce the powers we have to use trigonometric identities. Now we will write this as tan square x whole square dx. Now by doing that, what I am trying to do is I am trying to reduce the power of 4 to 2, because I can write tan square x as secant square x minus 1 whole square. Now this is in the form of a minus b whole square, so you know that I can write directly as a square that is secant to the power of 4x plus b square, that is minus plus 1, minus 2ab, that is 2 secant square x. So this is what we have to find out now, integral. Now everything seems to be fine, but we have again secant to the power of 4x, but don't worry about that, because we are going to separate that as secant square x and secant square x, and we will take tan x equal to t, and we will take care of this. And the integral of secant square x, we know already, that's nothing but equal to tan x. We know that integral of secant square x equal to tan x, because tan x derivative is secant square x. Okay, now let's go back to the next step. We'll write it as integral of secant square x into secant square x dx plus integral of 1 minus 2 integral of secant square x dx. Now let's try to go to the next step. Now we know integral of 1 dx is x, so I can directly write it down. I can say x here, and I can say here minus 2 tan x plus c. Now here what I will do, I will take tan x equal to t, so that secant square dx will become dt. I will take tan x equal to t such that secant square x dx will become dt. So I will have secant square x, I'll just keep it for some time, and dt. Now you know I cannot have this in x because I am having dt, so it will be nothing but secant square x is nothing but 1 plus tan square x. So can I write it as 1 plus t square dt plus x minus 2 tan x plus c. Let's go to the next one. Now that's equal to integral of 1 dt. Integral of 1 dt, this is easy now. Integral of t square dt plus x minus 2 tan x plus c. Now what is integral of 1 dt? T plus t cube by 3 plus x minus 2 tan x plus c. Now we'll do back substitution. For t it is nothing but tan x, and t cube by 3 is tan cube x by 3 plus x minus 2 tan x plus c, which is nothing but equal to, the last step is tan cube x by 3. I have plus tan x here minus 2 tan x, so can I write it as minus tan x plus x plus c. I have tan cube x by 3 minus tan x plus x plus c. So how we have done this? We have to do integration of tan to the power of 4x. So we have applied the formula tan square x equal to secant square x minus 1. Now why we have done that? Because when we try to get the function in terms of secant square x, we know integration of secant square x. Integral of secant square x is tan x. And if I have secant to the power of 4x, then I can take tan x equal to t, and then I can write secant square x is nothing but 1 plus t square, and another secant square x will become dt. So it will become 1 plus t square dt, which is very easy because we know integral of 1 plus t square dt is t plus t cube by 3. So that becomes very easy to deal with. So we have to look into the options how we have to go ahead so that we can simplify this and get it transformed into those functions for which we know the integrals. Let's go to the next one. We have to find the integral of sin cube x plus cos cube x divided by sin square x cos square x. So we'll try to separate them now. I'll write it as integral of sin cube x divided by sin square x cos square x plus integral of this dx here plus integral of cos cube x dx divided by sin square x cos square x. So my next step will be, if I simplify, I will have sin square x will go sin x times. So I will have sin x by cos square x dx plus integral of cos x dx by sin square x. Now we'll try to see what these functions will become. Sin x by cos x is tan x. So can I write it as sin x by cos x into 1 by cos x dx plus integral of cos x by sin x into 1 by sin x dx. Now this is nothing but equal to integral of tan x secant x plus integral of cot x cosecant x, for which we know already the integrals. We know that integral of secant x plus tan x is nothing but equal to secant x, and we know the integral of cosecant x cot x is nothing but equal to minus cosecant x, because integral of cosecant x is minus cosecant x cot x. Integral of cosecant x is minus cosecant x cot x. Since we have plus here, it will become minus cosecant x plus c. So we have just separated them and we got them into the function for which we know the integral. Let's move to the next one. We have to find the integral of 1 by sin x into cos cube x. We can do this in two ways. One way is, the first approach is, take 1 equal to sin square x plus cos square x. Sin square x plus cos square x equal to 1, and the second approach is multiply and divide with cos x in the denominator. Cos x you multiply with cos x in denominator. That's two options you have. Let's look at the option 1. We will solve it in both the ways, it's easy. So 1, I will have sin square x plus cos square x divided by sin x cos cube x. This is the problem. So we'll try to separate them now and write it as integral of sin square x by sin x cos cube x plus integral of cos square x by sin x cos cube x dx. Now we'll separate them. We will simplify. We will have sin square x by sin x is sin x. So can I say sin x by cos cube x dx plus integral of, I have 1 by sin x cos x So next step will be, now this is nothing but equal to integral of sin x by cos x into 1 by cos square x dx. Let me write it in the next line. Equal to nothing but integral of sin x by cos x into 1 by cos square x dx plus integral of, now see here I have sin x cos x, but if I multiply and divide with cos x, what this becomes? This becomes sin x by cos x into cos square x. So can I write it as sin x by cos x into cos square x? So I'll write it as sin x cos square x by cos x will go to the top. Let's go to the next step. We will have integral of tan x secant square x dx plus integral of, now cos square x will go to the numerator, it will become secant square x, and in the denominator we have sin x by cos x, that is tan x. This is nothing but equal to, if I take tan x equal to t, if I take tan x equal to t, let me write it down here. If I take tan x equal to t, then secant square x dx is equal to dt. So can I write it as t dt plus, again I take tan x equal to t, I have secant square x dx is equal to dt. So this becomes dt by t, which is equal to, now we know integral of t is t square by 2 plus log t, which is nothing but equal to tan square x by 2 plus log of tan x plus c. So the answer will be tan square x by 2 or half tan square x plus log of tan x plus c. So what we have done, we have used the first method. Instead of 1 we have written it as sin square x plus cos square x. What I want you to do is try to multiply and divide with cos x. So it becomes like sin x by cos x, again cos x. That's the second method. Then you will have tan x and cos to the power of 4x. So this becomes secant to the power of 4x by tan x. Now can you try this way and see whether you are getting the same answer or not? What we will do, we will multiply and divide with cos x. So it will become tan x secant to the power of secant tan x in the denominator and secant to the power of 4x in numerator. We will take tan x equal to t. Obviously secant square x dx will go as dt. One more secant square x is left out. You can write it as 1 plus t square. So it becomes 1 plus t square by t dt integral, which is nothing but equal to, you will have integral of t plus integral of dt by t, which is nothing but the same answer. To try it that way also. Okay, let's go to the next one. We have to find out the integral of cos 2x dx by cos x plus sin x whole square. So in this type of problems where we have denominator with a power, the complicated part here is cos x plus sin x whole square. Remember, in integration, whenever you see in a given in a problem, you see the part which is in square roots or in powers, always look to make that as t and try to convert your numerator as part of the derivative of that. So what I will do now is I will take cos x plus sin x equal to t. Suppose I take sin x plus cos x equal to t, I know that my dx is cos x minus sin x dx is equal to dt. How? Sin x derivative is cos x derivative is minus sin x is equal to dt. Now how I have to get here in the numerator cos x minus sin x? For that I will look into the identity. Cos 2x is equal to cos square x minus sin square x, which is in the form of a square minus b square. So I can write it as cos x minus sin x into cos x plus sin x, which is nothing but a minus b into a plus b, that's equal to a square minus b square divided by cos x plus sin x whole square. Now this seems to be okay because I got the dx, I got the derivative. Not only that, I am also saying something is cancelling it out. So we have here left out with cos x plus sin x. So it will become integral of, if I cancel them, it will become integral of cos x minus sin x divided by, now it will go one time, so you are left out with cos x plus sin x or sin x plus cos x and dx here. Now we know our x is sin x plus, so our sin x plus cos x, so it will become t here, and cos x minus sin x dx is dt. So we have integral of dt by t, which is pretty easy, log of t plus c. Now what's our t? Our t is nothing but equal to sin x plus cos x. So it will become log of sin x plus cos x plus c. That's our answer. So how we have done that? Whenever we have a function for which we have to find out the integral, always we have to look at the complicated part. The complicated part is the one where you have powers or which is in square roots. So we try to take that as function and see how we can get our numerator converted into a derivative of that particular function. So if I take the substitution sin x plus cos x equal to t, cos x minus sin x dx is equal to dt. So I have to manipulate my numerator in such a way that I will get cos x minus sin x there. So for that I recollect that cos 2x equal to cos square x minus sin square x, which is nothing but equal to cos x minus sin x into cos x plus sin x. Now when you substitute that, you will see that this becomes simply integral of derivative divided by whatever the derivative divided by the function, or it's nothing but equal to of the form of, this is the form in which it is. The form is, we have integral of f dash x divided by f of x, which is obviously nothing but equal to log of f of x plus c. So that's a format in which it is. Okay, let's go to the next one. This is an interesting problem. Let's have a look at this. We have to find out the integral of 1 by cos x minus a into cos of x minus b dx. Now we don't have anything in the numerator. In the denominator we have a product of two functions, cosine functions, that is cos of x minus a, cos of x minus b. So how to move forward? Only the thing we know is that if I do x minus a minus of x minus b, I will get a constant because x and x will cancel, minus x plus b, I will get b minus a. So now if when I know that if I subtract that, I am going to get a constant. So can I apply a trigonometric function on that, like say sin of a minus b or sin of b minus a, multiply and divide with that, then manipulate that constant as nothing but equal to sin of x minus a minus of x minus b. Then you can write down the formula sin of a minus b sin a cos b minus cos a sin b. Then some of these parts should be cancelled out. So what's the approach we are trying to look into? The approach we are trying to look into is, we see that there is nothing in the numerator, so we want to get a constant there and we want to apply trigonometric function on that. We want to manipulate it in such a way that we can write it in the form of sin of a, something like sin of c minus d, which is sin c cos d minus cos c sin d. Then obviously we should be able to cancel out some of them, remaining should be easy to integrate. So that's the idea. So what I will do for that, the first step we will do, multiply and divide both numerator and denominator with sin of a minus b. Now I will tell you at the end of the problem why we are taking sin of a minus b, why are we not taking cos of a minus b, because at the end a minus b is a constant. You can apply any function on that. What is the advantage you are getting by taking sin instead of cos? Okay, let's go to the next step. This is nothing but equal to, now sin of a minus b divided by sin of a minus b, multiply that with 1 by cos of x minus a and multiply that with cos of x minus b, which is nothing but equal to, I can get sin of a minus b out. I will have integral of, now this sin of a minus b, how I will write it as? I will write it as sin of x minus b minus of x minus a. I hope you are okay with that. That divided by, you have cos of x minus a, multiply that with cos of x minus b. This is nothing but equal to, we have 1 by sin of a minus b out. Now see here, you have sin of c minus d. That's nothing but the formula sine of a minus b is equal to sine a cos b minus cos a sin b. Now the idea is to cancel some of the denominator part of the denominator and try to get it into a known integral function. Okay, right. Now 1 by sine of a minus b. Okay. After that, what I have here now, sine of a minus b. This is my capital A and this is my capital B. The formula is here. So we have sine a cos b. Can I write it as sine of x minus b cos of x minus a minus sin a cos b minus cos a sin b, that is cos of x minus b into sin of x minus a whole thing divided by cos of x minus a into cos of x minus b. Now we'll try to separate them and see what happens in the next step. That's equal to, we can write it as 1 by sine of a minus b, then we'll say integral of, now you can see I can write them separate as sine of x minus b cos of x minus a divided by cos of x minus a, shall I put a bracket here, cos of x minus a cos of x minus b minus, again we have integral of, this is dx, we have again integral of cos of x minus b, multiply that with sine of x minus a and divide that with cos of x minus a and cos of x minus b, and we have a dx here, here too. Okay, now if we simplify, we will have cos x minus a cancels here, and cos x minus b cancels here. So I have 1 by sine of a minus b integral of tan of x minus b minus integral of tan of x minus a dx. Both of them are separate and they have a dx. So this is nothing but equal to 1 by sine of a minus b, then I have integral of, this is nothing but integral of tan x is minus log cos x. How we got it, we'll write it down here, I'll show it to you. Can I say sine of x minus b by cos of x minus b dx? I should have done that, kept it that like that only, but to explain you I am again going back. Otherwise integral of tan x is minus log of cos x, but I just want to show you how that comes. Sine of x minus a, then this step is redundant there because we are again going back to the old step. That's fine, only for you to understand. Okay, this is dx. Now this is what we have. Let's go to the next step. Now see here what happens if you take cos of x minus b equal to t. What is your dt? dt is nothing but minus of this, minus of your numerator. If I take cos x equal to t, dt is minus of sin x. So it's nothing but dt by t, which is nothing but log t, but there is a minus there. So we know already, we have seen that integral of a derivative of a function divided by the function itself is equal to log of the function. We have seen that. So can I write it as now 1 by sine of a minus b, and coming to the derivative part I will have this. Now I have t equal to cos of x minus b, so the derivative of that is minus of sin x minus b, so I have minus there, and this is nothing but equal to now minus of sin x minus b. So the derivative of that is minus of log cos x minus b. Then I have plus log of cos x minus a, and this is nothing but equal to the last step. Now we have log of x minus log of y. Can I write it as log of x by y? So it becomes 1 by sine of a minus b log of cos of x minus a by cos of x minus b plus c. That's the answer we have. So the answer is 1 by sine of a minus b, multiply that with log of cos of x minus a by cos of x minus b. We'll look into another maybe session where we can find out tan x cot x. We haven't gone through that, how to find out the integral, but it's simple. You have sin x by cos x, you take cos x equal to t, minus sin x dx is dt, so minus of log of cos x or log of secant x. Now coming to the point, now what I was saying is we have to find out integral of 1 by cos of x minus a cos of x minus b. Similarly, we have found that. Similarly, you can find out 1 by sine of x minus a cos of x minus b. Similarly, you can find out integral of 1 by sine of x minus a and sine of x minus b. Now the point to understand is like, now which constant I have to take and why only in sine or cos. See here, whenever I have in the denominator both the cos terms, my numerator should have sine and cos combination so that I will cancel them out. If I take cos of them, then one term will cancel, another term will become very difficult to integrate. Now whereas look here in the denominator we have sine and cos. This is a correct choice to go for cos of, because when I go for cos of, I will have cos a cos b minus or plus sin a sin b. So one of them will cancel, another will become cot. In the first case it became tan, in the second case it will become cot. Here we have went for sin of a minus b, here we will go for cos of a minus b. Similarly, here again you see we have sine and sine, that means again I will go for sine of a minus b. So can I say as a small tip that, or trick, that whenever you see the denominator having same combination of same trigonometric function, then go for sine. If they are alternative, if they are sine and cos or cos and sine, then go for cos. The idea is to cancel the part of the denominator, convert the remaining into tan or cot as needed. If you go for not the one which is needed, then you will end up on one side with 1 and the other side it will go into a little bit more tricky position, for which to solve out you need to put more effort. So the point to understand is, since I have cos of x minus a cos of x minus b, I went for sine of this constant and I manipulated it as x minus b minus of x minus a, so that I will have sine cos cos sin cos sine, something will cancel out and I will get tan of. Similarly here when I have sine and cos combination in the denominator, I should go for cos, because cos of a minus b will give me cos a cos b plus sin a sin b. So that is the approach we have to take. So I'll catch you in the next session. We'll try to find out the integral of some particular functions, like maybe we haven't seen what is the integral of tan x, cot x, cosecant x, secant x, and also we'll see what is the integral of one like dx by x square minus a square, or a square minus x square, or x square plus a square, or all of these in square roots. That we will look into. We will do some problems based on that. As we understand those formulas, we will do some simple examples on that. After that we will go into integration by partial fractions, then we will go to integration by parts. So I'll catch you in the next session. Thanks for your support. Bye for now.